Good morning, everyone, and welcome to the Sonatype webinar series, How to Empower Developers with Nexus. My name is Amar Hindi. I'm the Asia Pac Sales Director at Sonatype, based here in Sydney. With me is also Cameron Townsend, Solution Architect, Asia Pac, based also in Sydney. Before we start, I'd like to go through some procedural notes here, and then we can kick off the presentation. First of all, raise your hand if you have any problems with audio or any particular problems with the preso or the demo. During the webinar, all participants will be on mute. Please ask questions in the chat window bottom right of your screen. We will also, of course, address all questions and answer all questions at the end of the webinar. Additional questions, feedback, or individual follow-up requests can be sent to Hindi, myself, here at Sonatype.com. With that, I will start the presentation. It's about 8-minute presentation. We'll follow that with a demo. As we all know that the best companies build great software and innovate faster than their competitors. Netflix is a great example of that. The question is how? One of the reasons these companies innovate faster and better than their competitors is due to their adoption and utilization of an infinite supply of open source components in their applications. The graph illustrates this trend. Sonatype runs the central repository, the largest Java open source repository on behalf of the Apache community. And as we can see that in 2017 alone, we had 87 billion components downloaded from the central repository. Almost 70% growth in download requests compared to the previous year. Java components are not the only open source components out there that are experiencing exponential growth. As you can see here, pulls from Docker Hub have grown to 12 billion in 2017, doubling the amount of the year before. You can download, and I urge you to download the software supply chain report that we publish each year, where you can see the latest trends in open source component usage and download. It's available on our website at Sonatype.com. Most of open source components downloaded are good, but we all know that not all parts are created equal. And unlike wine, they all go bad over time. This means that you really need to identify which open source components have no security vulnerabilities or bad licensing risk in your apps. You also need to be very fast and accurate with your identification, or you will slow developers down. In addition, we know from our Maven Central analysis that cybersecurity hygiene is important and required. In 2015, we saw 6.1% of all downloaded requests were vulnerable. In 2016, this ratio decreased to 5.5%. However, in 2017, saw exponential growth of defective components downloaded. This has now reached a ratio of 12.1%. So you've got 12.1% of all downloaded components actually have security vulnerabilities. The companies pulling these security vulnerabilities from public libraries are running the danger of including these libraries in their software supply chain. But Java components are not the only vulnerable components out there. Further analysis shows that there is evidence out there that defects percentages for JavaScripts are also shockingly high, higher even. 87% of handlebar inclusions were known to contain vulnerabilities, and the ratio was around 40% for jQuery and Angular. This is the problem that we need to address today, and we'll show you how with the right tools and the right strategy. And don't just trust sort of our word for it. OWASP released their top 10 report, and in point A9 it states that companies should not be using OSS components with known security vulnerabilities. However, obviously that's easier said than done. We also know that 6 in 10 organizations surveyed by Sonatype have open source policies and try to enable their developers to innovate faster. Yet still these organizations get hacked. These are major events that get exploited across the media. As you can see from these clippings, many companies, notably Equifax in 2017, had massive breaches due to known OSS vulnerabilities. that could have been easily remediated had it been identified immediately. So how does the Nexus platform deliver DevSecOps? As you can see here in this standard development pipeline, speed is critical in order to innovate fast and beat your competition. You also need control across the entire SDLC in order to be able to analyze the OSS components that are in there and continuously monitor the new and old security vulnerabilities in your OSS components. With Nexus Intelligence, we're able to provide you precise metadata on polyglot universe of open source components. In addition, real-time updates from 78 public and 150,000 private sources, all curated by our team of 65 dedicated security and researchers, experts. You can trust your data. In addition, once you have implemented your successful strategies and tools, the Nexus control plane can identify, manage, and remediate your open source risk. We can contextually enforce policies everywhere and early, and the automated controls align the priorities of your development and security teams. Developers can use the best quality components, and the security team will have total visibility into what components are being used. Both teams have the ability now to recall bad components once the new vulnerabilities are identified. To be more specific, we have the Nexus Firewall, which can block OSS components when downloaded from public repos into your own repository. We also offer the Nexus repository to store and share your binaries locally. And finally, the Nexus Lifecycle, empowering developers with continuous intelligence, enforcing policies from IDEs and CI/CD tools, creating bill of materials and validating compliance at release, and continuously monitoring production applications for zero-day vulnerabilities. This is exactly what Cameron will be demoing in the next couple of minutes. Tyro is a local company here based in Sydney, Tyro Payments. They implemented the Nexus suite. Their challenge was to manage all aspects of open source usage in their application development process, security, licensing, application aging, and increase the speed of development. With implementing the Nexus suite, Tyro achieved immediate visibility of components being used, automated policy enforcement, security and licensing, and faster, better quality deployments. Finally, you will build security early in your CD pipeline, achieving DevSecOps. You'll be shifting security left. Fixing components early on saves 30% in cost versus fixing later. Automate your governance of open source usage. No manual process where it could take 2 to 4 hours to investigate a component. Only automation will deliver the speed and precision that you need. With the right tools, you can improve development efficiency, have less unplanned work, fewer break fixes, easier maintenance while increasing quality. With that, I will turn over to Cameron, who will actually demo the Nexus Lifecycle, and I will also be monitoring for any questions.
Yes, so thanks, Amar. So as Amar was saying, the big challenge we have today with securing application software is this exponential use of open source. And what we're finding is 89% of modern applications use open source components. And this actually starts at the IDE level, at the development environment. When the developer actually starts working on a project, they start consuming open source very early in the project. And so what we decided to do at Sonatype was to create a plugin here for the Eclipse IDE, as an example, to show the developer these components and do a security assessment on them immediately. And this is this idea of shifting security left, because if you actually are working on a project and you consume a component and then it shows you here in the environment that it's vulnerable to exploit, you're going to fix it straight away because it's right in front of you. And traditionally, developers and security professionals have this constant struggle about who owns security. And with DevSecOps and this new trend of empowering developers all the way through the life cycle of a project, we're actually giving them the tools in their IDE to fix it as well. So for example, Commons Collections here, I'm actually using this library, Commons Collections 3.2.1. And this is my screen here, this is our plugin. And it's actually showing the developer all of the libraries that he's using, or she's using on the project. These ones in the bold color are direct dependencies, and the grey ones are actually these, what we call transitive dependencies. These are dependencies that are actually brought in on the back of other libraries. And traditionally, developers might not have even been aware that those libraries were in their project, let alone that they were actually bringing in known exploits for attackers to take advantage of. This particular one here, Commons Collections 3.2.1, is actually quite an old library. It's about 10 years old, and the vulnerability was found about 3 years ago. So for 7 years, people were using it, not aware that they were vulnerable. And in fact, I travel all around the world now, especially extensively in Asia, in Hong Kong, in China, Taiwan, Korea, and I see this library pretty much everywhere I go. And this particular version, 3.2.1, is used by nearly every team that I've ever worked with. And the reason why is because they're not aware that there's now a vulnerability being discovered in that library. And they sometimes think it's also difficult to remediate. So we try and help you from Sonatype. We give this remediation advice to you to show you how to fix it. And I'm just going to take you through some of the steps in remediating this problem. Firstly, we tell you here on the right the group, artifact, and version. So this is this precise identification of the component. This is actually where the security assessment starts from our side, because the key to finding and fixing these vulnerabilities is having very accurate data. So no false positives, minimal false negatives, so that you can really trust this tool, and the developers can then rely upon it to fix the project very early on. We have here as well this declared, observed, and effective license. What they are is the declared license is actually what's in the header of the library that was brought in. The observed license is something that we at Sonatype do with Java projects. We actually expand out the classes in the Java project and have a look at the licenses that might exist in all of those classes. And if we see one, then we will report it here in the observed licenses. And sometimes you'll actually find projects have multiple licenses in them. And this will actually show up here in this particular screen. And then the effective license is the license that you're responsible for as a project team or an organization. The highest policy threat here is actually level 9. And I'm going to show you in a minute how to set policies up. The policies are very context specific to your organization. We give you some policies out of the box, but you can actually tweak the policies. So you might have an application that has a higher risk profile than a different application. So you can set policies that are suitable to that application's risk. Then we show you also here the security threats. There's actually a level 9. That's based on the CVE, or the Common Vulnerability and Exception scoring system. We also tell you how old it is. It's 10 years old, and it's an exact match. What the exact match means is that the hashes match exactly between what Sonatype has and what you have in your organization. On the right here we have the slider, we call it, and this slider is giving you the history of the Commons Collections project. So this particular version, 3.2.1, is the one that you're using, and this vertical line through here is telling you that your one has a known security alert, the red triangle there. But to the left, these are older versions, and then to the right, these are newer versions. And if we look carefully, there's this one here, 3.2.2. It's got no red triangles, and also it's becoming quite popular. So as people become aware of this vulnerability, it's getting more and more usage. So I can actually click on that and hit this migrate button, and I can actually fix that vulnerability straight away. It actually edits my POM file for me in the Eclipse system there. I'm just going to save and build that. And what will happen is that will actually pop off now. That Commons Collections is gone. So I can actually then go on to my next vulnerability. This BSH one here, again, it's very old, and so on and so forth. And so the idea is that you actually work your way through the project, removing the vulnerable libraries very early on in the project. So each of these is actually scored based on their policy violation, and I've actually got it sorted here by policy violation. So if I have a look, I've got a number of critical ones here. Then I've got these orange ones that are medium. They might have medium security issues. And then I have these light blue ones. These light blue ones are okay. There's no known security vulnerabilities in them. And this is the power of open source, in fact. This is why developers are using open source, because there's a lot of functionality in here. And for your company to write all of this software from scratch would be an unsustainable task. And so development teams are being pushed to write software more quickly, and they're doing it by using these open source libraries. But unfortunately, some of them are vulnerable to attack. And the idea is that you use a tool like Sonatype to actually remove the known vulnerable ones from your system. And then you can work as security professionals, for example, to coach and work with the developers on that sort of 10 to 20% of custom code that they write, looking for unknown vulnerabilities. But just before I show you how to set the policy up, I'm going to show you a couple of examples of how these known vulnerabilities expose themselves in the real world. And one example of that is I can actually do a Google search, what's called a Google hack or a Google dork, that will find applications written using a framework called Struts. And the way I do that is Struts generates pages with a signature. And their signature looks like this. So these pages, 459 million of them, I know these are written in Struts. And not only that, if a vulnerability is published on Monday, typically what will happen is there'll be a patch released as well by the development team, as what happened with Struts last year. But if I'm an attacker, I know that I have a first mover advantage over the company that owns this system, because I can attack you more quickly than you can patch your software. And I can even target this to a particular company. Equifax is probably the most famous one. And if I limit the search here, this is actually going to filter all of those Struts web pages that are at Equifax. So it's very quick and easy. It's taken 0.44 seconds for me to find a list of targets. And so if I break in, I can actually then use exploit kits that are actually out there in the public domain. In fact, some of these kits even have service levels that they will promise to deliver you a new attack, within 48 hours of one being published. So it's becoming a more and more difficult game for companies to protect their assets from hackers, because not only do these exploits exist, there's also Bitcoin, which allows you to monetize the attack. And Bitcoin or whatever, Monero, whatever these cyber currencies are, they're anonymous. And so you can actually then take the money out, and it's very difficult to track you. This is becoming a bigger and bigger problem for organizations. In fact, probably the most famous one that we know about is Equifax. And I'll just show you this article. This is Equifax here. The CIO at Equifax was actually charged with insider trading, because what he did, unfortunately, was he sold his shares in Equifax before they announced the breach. And the SEC in America is now pursuing him for insider trading, and that's a criminal offense, which is as bad as these vulnerabilities get. So what I'm going to show you now is I'm going to show you how those policies are set up, so we can actually try and fix this problem before we get into the newspaper, which is not what we want. This is the IQ server here. This is the policy engine, and these are the policies that we give you out of the box. We have security. We have these organizational hierarchy here on the left, so you can set up different levels of your organization with different applications. And they can have different policies depending on what sort of applications they are. So for example, we have this idea of a distributed application, a hosted, and an internal. Distributed means that it's like a mobile phone application, something that you ship to your end users perhaps, like a net banking, mobile phone banking application. Hosted is something that you have on your servers at your premise that is externally facing, and then internal is an internal application that you might have other ways of mitigating the risk associated with that. And then we give you these policies that are built in, but you can actually add and change these, remove these, make different ones depending on your particular requirements. And what I'm going to do is I'm going to show you, and this is licensing and security and architecture. I'm going to show you now how we create a policy, and then how we interact with your different DevOps tool chains to create a DevSecOps pipeline. So the first thing I'm going to do is I'm going to give this policy a name, security demo, and I'm going to give that a threat level. That again is something you can configure. I'm going to check the security vulnerabilities. Again, this is just a name that you can give it. And I'm going to go and do a security severity here. Just picking the number 7. So I'm saying anything with a high security problem, I'm going to actually start blocking that. Now what you can do is you have these actions, and these actions correspond to the software development life cycle, the different stages of how you deliver software at your organization. The proxy is basically the downloads. You can actually stop developers even downloading libraries if you want to do that. That's what we call the firewall. But what I'm going to do is I'm going to actually put in some rules here saying that I'm going to warn developers, say, please don't use this, but I'm actually going to stop the developers from releasing it into production. So you can actually block it if you want to do that. And then we have integration, for example, with Jira. We can actually create a Jira ticket. And so I can actually add that, and I can also send emails, for example. So what I'm going to do now is I'm actually going to set up this policy to notify me if something happens. We also have continuous monitoring. The continuous monitoring will allow you to, for example, monitor applications that you've already released, some of your legacy applications that are in production. You can monitor those, and we will look for new vulnerabilities in those every day. So you get like this 0-day alerting when new vulnerabilities are discovered in your applications. So these policies have been set up, and now what I can do is I can actually go into my Jenkins, for example, and we have integration with most of the popular build tools out there, and we can simulate doing some builds. I'm actually going to trigger these builds here while we're doing the discussion. And if you notice, the duration is very quick. These take about 30 to 40 seconds to run. So our scanning is not only very accurate, it's also very quick. And the reason why it's so accurate and so quick is because we use this hash matching algorithm. And the hash match will actually take a cryptographic hash of each of the libraries in your project, send those hashes in a request, and then our server will respond with the metadata around those hashes. And that's retrieved from our knowledge base. And our knowledge base is constantly being worked on. We have 65 full-time data researchers. We also have automatic vulnerability detection systems. So these builds have already finished here. They're marked as unstable because I told them to mark as unstable, as to warn. And if I have a look here, I have this report that's actually come up. And this report acts as a bill of materials. This shows you all of the components that were actually in that build in Jenkins. And this is our project. We show you the security issues. We also show you this dependency tree here, showing you that there's vulnerabilities 1, 2, 3, 4, 5 levels down in the tree. We show you licensing information. And then we have a number of tabs here as well. We have this policy violations tab. This gives you all of the libraries that are in the project. It acts as the bill of materials. We show you the component, the file name, the popularity, and the age, and the history of that project. And if I want to look at one of these libraries like Commons Collections, for example, this is the same view that the developer had previously that I was showing you in the IDE. And we actually show you here the history of the project, that it's vulnerable to attack. And this vulnerabilities tab here will actually show you the details of the vulnerability. And I'm going to click on the enhanced data research we have on that. And this shows you the work that our data research team does. So firstly, this particular vulnerability, we had this 82 days earlier than there was a CVE published. And the reason being was that we discovered this vulnerability from a blogger who reported it. And he had actually reported it to the project team, but they actually resisted creating a CVE. And so we actually created our own problem code for this so that you know about it earlier even than CVEs. And also with modern systems like JavaScript, for example, nearly all JavaScript vulnerabilities do not have CVEs in them. They do not publish CVEs so much anymore in these new ecosystems, unfortunately. They tend to just fix them in GitHub and move on. And we track that as well with our AVD system, our automatic vulnerability detection system, scanning GitHub events every day, looking for these vulnerabilities that might be discovered. But just going back to this one here, we actually have a recommendation as well. So we're telling you, we recommend upgrading to a version of this component that is not vulnerable to this specific issue, which means, upgrade to a new version of the library. We also tell you about a potential workaround if it may exist. And then also we have like these advisories and different articles that have been found about the vulnerability. If you want to show that to the developers, if they push back and say, look, this is not a problem, you can actually take them to the research, and this is the article that actually shows the nature of that particular attack, explaining how it works and so on. We have this tab here for the security issues. We actually call out each of the CVEs and Sonatype codes that have been found. So there are some CVEs here, public ones, but there's also these Sonatype ones that I was mentioning. And then we also have licensing issues as well. So this actually tells you about licensing, if you've got GPL or any sort of restricted licenses being used in those components, so you're aware of it. So every one of these scans that I've done actually goes into the dashboard. So this dashboard can become a control center for all of your applications that you're using across your organization. So these actually happened 3 minutes ago. We also list, for example, the most vulnerable components. So this particular one here is HTTP client, for example. I've got that in 19 separate applications. And so someone might come to you and say, oh, are we using struts? Are we using this library that's just been announced in the newspaper? We can answer that question very quickly. This is Bouncy Castle. It's famous. I can click on this. It's 13 applications here. Are all include that particular library. And then finally, we also tell you which applications are the most vulnerable. So you can go and talk to the developers of that application and say, look, your application is one of the most vulnerable in the whole organization. Let's spend some resources on remediating those issues. And better yet, let's give you the tools in the IDE so we can actually remove those vulnerabilities before you actually put them into the system in the first place. Fix it on day one. Yeah, let's fix it on day one. So that's a view of the report there. Let's just go back quickly to Jenkins and have a look at how Jenkins is going. Yes, all those builds have finished. They all took about 30 seconds. So while I've been talking, I've actually done 4 builds with scans and so on. We've actually seen these ones here have failed. Every single build as well, for example, gets a report in it. So if I could see the history here, I can actually see this application composition report, which is the Sonatype report, for every single build. I can actually also look at the console here. This is a Jenkins view of all of the components that were scanned in that particular project. And it also tells you that the policy here was violated. All of these libraries breached the policy. If I can then click on this report and view the details of it. And this report here is then able to be seen from many, many different places. But we always go back to this lifecycle server to see the dashboard or to see the reporting. And it's a consolidated dashboard for you for all of the applications that you might be scanning across the organization, whether it's from Jenkins or even you can use a command line interface. And we have a manual upload as well. So there's lots of different ways of triggering builds. And it's very easy for you to onboard many, many applications because the idea is that you scan a directory or a release folder using our command line tools, and it can onboard those applications very quickly. We did one bank in America. We onboarded 10,000 applications in a couple of weeks. So it's very scalable, it's very powerful, and we have 8 of the top 10 software companies in the world, 8 of the top 10 banks in the world. Most of the US government and military are using these tools, and we're finding more and more organizations in Asia Pac are using it as well, especially in Singapore and Hong Kong and Korea and China. So that's the end of the demo. I'm going to hand it back to Amar now and hand it over to you for questions.
Thanks, Cameron. We do have a number of questions. The first question, the list of public repositories that we actively monitor.
So the public repositories that we actively monitor, so there's things like Maven Central and NPM and PyPy, Ruby Gems and so on. Plus we also track GitHub for security related events. And we also have our own proprietary tools that scan, for example, blogs and security researches and articles. There's tens of thousands of them.
There is a specific question on
Closures?
Closures, yeah.
Closures.org. I'm just trying to remind myself what closures.org is. Can I get back to you on that specific one? I don't know the exact answer to that off the top of my head. So
I have the person who asked the question, so we can get back to it.
Yeah.
Okay. But I would add to what just Cameron mentioned. Basically, the ecosystems that we monitor tend to be Java, JavaScript, .NET, and and many others. And so it's depending on the ecosystem that you're using. So if it's a Java, JavaScript, .NET, then we have support for them.
There's a question about exact matches as well.
Yes. So the next question.
Yeah.
The next question I have is what basically the reference to exact versus similar matching.
Yeah, sure. So the way that works is that the first pass through, we take a hash of the jar, and we match the hash. For example, we match that hash against our list of known hashes. If the hashes do not match, then we do a technique called secondary expansion, and this is a proprietary algorithm that Sonatype has developed. It's actually got a patent pending on it, and what it does is it actually looks at all the classes in the jar, and then it looks at those classes, it hashes them as well, and matches those hashes against our list of hashes for all the classes that we've analysed over the years. And if we find a sort of a high level match, sort of, it's a heuristic, but it's approximately 80%. If we find, say, 80% matching of the classes, then we'll call it similar. So typically that happens when, for example, the developers have downloaded the source code and maybe they've made a modification or altered some of the code. When they compile it, the hash will not be the same because there's been a change, but the classes will be the same or similar, and that's where the similar matching will come in. If the matches drop below that 80%, say, then we'll say no match. So that's the algorithm.
Okay. The other question that we have is, what is the difference between your data and the public information that is available on security vulnerabilities? Yeah.
So this is a very common question. The difference is really about the way that we approach this. We came at it from a developer's background, and we said, okay, how could a developer use this in a real world situation? They want very accurate data. They want data that can be automated. They do not want lots and lots of false positives. And because that was our design principle from the start, we have a completely different architecture than what, for example, maybe some other tools do. So the first thing we do is we take a hash match of the library. We don't just take a simple name match. So for example, there's a tool called Dependency Check, which has a simple name match. So if you have a very slight difference in the name, that tool will not match, and so it'll fall over. That's a major problem that's a free tool. That's a major problem for that tool. So we don't have that problem. Firstly, we match very accurately on the hashes. And then secondly, we have a team of researchers. So we ingest data from the CVE, from the public data, but we also add to it using our data researchers. And so they will actually then find vulnerabilities. And they will also do, for example, check the version range. So sometimes when a CVE is published, there'll be what's called a CPE, which is a linkage between the vulnerability and the library. And that CPE could be slightly out. It might be like a wildcard, or it might be the version range is slightly wrong. So because we check that, we get the exact library and the exact version range, and we find the exact vulnerability and where it lives. Our researchers even go and look at the code, and they'll actually say, oh, the code was actually introduced in this version. And so there might be an alteration to the CVE sometimes. So it's a huge amount of work that we go to create very accurate data. we deduplicate data, we look for false positives and false negatives so that you don't have to. So you can really trust the automation in the tool because that work's been done for you.
Another question is your solution dependent on a particular repository?
No, it's not. We do integrate with repositories, but there's no dependency on the repository, and it works fine. In fact, the demo that I've done today with Lifecycle did not use the repository at any stage. So there's no dependency on the repository.
Next question, I think that's the last question that we have. When a library includes parts of another library and or customizes it, the risk of this library not being updated is higher. It's bad practice, but it happens. Does your hash matching algorithm detect such libraries? Yeah, exactly. That's a really good example of how our hash matching algorithm will highlight that. So what will happen is that will come up as a similar match. And so, in fact, Cairo actually has now got a policy in their organization that they do not allow similar matches because of the exact situation that you described, because there's security issues, but there's also licensing issues and intellectual property issues potentially, and also you've now got an upgrade problem because you can't upgrade your library because you're no longer using the official one that everyone else in the world's using, you're using your customized version of that library. So yes, it's a bad practice, it does happen, and we will definitely flag it and tell you, we'll call it a similar match and tell you about it. And then you can go to your developers and actually address it. So that's actually one of the big use cases for our similar matching tools. Okay, folks. I don't have any other questions. I do have one follow-up, which is we will get back to the person that asked the question. We will be sending a copy of this recording to everyone. And as I said earlier, if you have any questions or follow-up questions, or suggestions, please email to ahindi@sonatype.com.
So Naveen has a question here as well, just quickly. So Naveen asked, do you have guidelines for testing the exploitation of a vulnerability? The answer is yes, and we actually show you that, for example, in the Commons collections. I actually show you how that works. Typically, that information is also publicly available through other places like Metasploit and places like that. It's not the main goal of what we do, but we do show you that about how the exploitation will work, and also about the detection for it in your code. So we'll actually give you guidance on that. Yeah. So Jonathan's just asking here. Yeah.
I just posted my email address in there if you need to have any questions. If nothing is coming up right now, myself and Cameron, thank you all for attending. As I said, we'll send the recording to everyone, and I look forward to perhaps seeing you guys or doing more specific demos to each of you. Thank you very much.